Hi, everyone. Well, this is it. The final lecture in Statistics for Psychology. I hope you have enjoyed the adventure. I know that you probably banged your head against the wall a couple of times, but learning new things isn't always easy. All right, so just to refresh your memory of where we left off, we were talking about regression. And we learned that there is a formula that we use, and this formula is actually used for two reasons. One is that it allows us to draw the best fitting line on a graph, on a scatter plot, and that best fitting line minimizes the average distance that points are to the line. So you can say it's minimizing errors in prediction. Why do I say that? Because we use the line to make predictions, right? We learned that formula not only calculates that straight line, but you use that same formula to plug in a specific value of x. So I would say, x equals 10 or x equals 13, whatever x is. And I give you that value, and you can use the equation to predict what y would be. All right. So the equation then draws the straight line, and the equation allows you to make predictions for a given x. What is y? Right. Now, there were lots of other things that we learned about, and of course, I encourage you to go back and review the lecture if need be, either by watching the video again or reading your book, or maybe even both. All right. But we do need to finish up the material, so we are going to continue our discussion of regression, and we're going to start with the question, how do we know if we are predicting above chance levels? All right. Now, SPSS, when you run a regression analysis, the output will give you lots of statistics that you can look at. And looking at those statistics is a good way to gauge whether you are making predictions above just guessing. Because, of course, why use regression? If it's no better than guessing, you may as well just guess, right? All right, now, so the first thing that you're going to look at in the output is the ANOVA. When you run a regression analysis, it actually gives you an ANOVA table. And we call it just the ANOVA for regression. And you need to look at the sig value for the F, because remember, ANOVAs calculate F values. So you look at the sig value, and if it's less than 0.05, then that tells you that your regression analysis is significant, which means you are probably predicting above chance levels. Now, this is the best way to know. But there's other things that you can look at that will also confirm and support your conclusion that you're probably predicting above chance levels. So the second thing you can look at is the size of your R value. And of course, this is a situation where bigger is better. If you have a larger R value, it means you have a stronger relationship between X and Y. And remember, it doesn't matter if R is positive or R is negative. The sign only tells you whether X and Y are both moving in the same direction, or if X and Y are moving in opposite directions. So the size of the R value, the actual number, is what tells you the strength of the relationship. So the larger the value, the stronger the relationship. And the stronger the relationship, in all probability, the better our predictions will be. All right. So this is another thing that you can look at when you're trying to figure out whether or not you're predicting above chance levels. Third thing is to see if the slope is significant. And that is also part of the SPSS output. Right? And so what you want to do is you want to see whether or not the slope is significant. If it is, it's telling you that the slope is significantly different from 0. Now, why is this important? Because the last lecture you learned that if the slope is statistically equal to 0, it means that there is no correlation between x and y, right? Let me repeat that. So if your slope is 0 or statistically equal to 0, in other words, if the slope is not significant, it means that there is no relationship between x and y, and essentially all you're doing, if you use one to predict the other, is you're guessing, okay? So on the other hand, if your slope is significant, that means it is statistically different from 0, which means that there is something going on. There is a relationship between x and y, and there's a good chance that you will be predicting above chance levels. Again, you should look at the ANOVA though, right? This is just confirming what you think you know. Now, also remember, just because your slope is not 0, all that tells you is that there's some relationship between x and y. Remember we reviewed last class that it's not always going to be the case that the greater your slope, the higher that number, the stronger your relationship, right? I showed you an example of where that logic breaks down. But at least you know if your slope is not 0, then something is there. And the last thing would be to look at sy.x, standard error of estimation, also called standard error of the estimate. And basically what you want to do is see if that's big or small, if that number is big or small relative to your x and y values. If sy.x is a lot smaller than your x and y values, then that means sy.x is a small number and you don't have a lot of error in the scatter plot. That means you're probably predicting above chance levels. But if sy.x is as big as your x and y values, or bigger, then that's telling you that sy.x is really, really big. And that means you have a lot of error in your scatter plot. There's a lot of scatter. That means your predictions are probably going to be pretty bad. All right? On average. Always on average.